Okay, so today we're going to review the chapter, Unit 2 on trigonometric identities up here. And what we're going to do is we're actually going to review for the test. Now, a lot of these questions are questions you've already seen on the quiz, so they shouldn't be, some of them should sound a lot familiar, but you should be able to work through them. So let's start. Alright, so the first one we have here is that it asks us if secant is 21 over 8, we want to find a cosine of beta. So again, remember, it doesn't really matter what's inside here. The beta is kind of just to throw you off. It could be a theta or an x. So you're really just doing the same question. So how do we do this one? Well, this one's actually really simple because if we say that cosine of beta, well, we know that from our old definition of right triangles is adjacent over hypotenuse. Then that actually means that secant, which is what's called the reciprocal identity of cosine, is just hypotenuse over adjacent. So if we know that secant is 21 over 8, all we have to do to get cosine is just flip secant. And so we know that cosine of beta is just going to be 8 over 21. Okay, let's look at number 2. So this one's a bit more involved because we're asked if secant is equal to 2 and sine of x is equal to the square root of 2 over 2, we want to find cotangent. Well, first of all, let's talk about what cotangent is. Well, cotangent is just cosine over sine. And we ask ourselves, well, do we know either what cosine or sine is? And actually we do. We know that sine, as we're told here, is just the square root of 3 over 2. So we just put that in the bottom. What about cosine? Well, we're given secant, so how do we get cosine from that? Well, again, you can actually look at the last problem. And remember that secant is just the reciprocal identity of sine. So that if secant is 2, well then that just means that cosine is 1 over 2, or 1/2. So we just put that in the top as cosine. So what we get is we get that cotangent is 1/2 over the square root of 3 over 2. So we just say, okay, well, cotangent is going to be equal to 1/2 over the square root of 3 over 2. So notice what we're doing. We're actually dividing fractions here, right? We're actually dividing fractions. So how do we do that? Well, what we want to do is, again, remember that this big bar in the middle, we can just treat that like a division sign. So that's 1/2 divided by the square root of 3 over 2. And then we do our little trick when we're dividing fractions, which is we keep the first 1/2. We change the division to a multiplication, and we flip square root of 3 over 2 to 2 over the square root of 3. And so we get that we're multiplying 1/2 times 2 over the square root of 3. We have a 2 in the denominator times a 2 in the numerator, so those will cancel. And we end up with 1 over the square root of 3 as our answer. That's what cotangent is. Okay, let's look at number 3 now. Alright, so we're asked, what is this equal to? Right? What is this trigonometric function equal to? Well, you have to think, what do we need, right? Well, we need a common denominator to do anything. And to get a common denominator, what we have to do is multiply each of these fractions by the denominator of the other fraction. So here we have 1 plus cosine, so we're actually going to multiply this by 1 minus cosine of theta, which again is the denominator of the other fraction. But we can't just go around multiplying functions by stuff just to make it work out, so we have to multiply 1 minus cosine theta in the top as well. Over here, instead of 1 minus cosine, we're going to multiply this 1 minus cosine by 1 plus cosine of theta. And then at the top we say 1 plus cosine of theta as well. And I like to put parentheses around them. Okay, so that gives us a common denominator of 1 plus cosine theta, 1 minus cosine of theta. It doesn't really matter, but let's keep them in order. And so what do we do about the top? Well, this sine actually gets multiplied, gets distributed to both the 1 and the cosine. So that's going to be 1 sine of theta plus sine times cosine. So this is kind of a identity or a trigonometric function in itself, right? It's not sine and it's not cosine, it's actually sine and cosine multiplied by each other. So that gets put together as one little piece. Same thing with this one. Distribute the sine to both terms. We're going to say sine times 1 is just sine. Now be careful because there is a negative right here. So we're actually going to put a negative in front of that and we're going to get sine theta times cosine theta. And so what happens? Well, we notice the sine times cosine and a sine times cosine, there's a positive and a negative one. So those two will cancel. And we end up with sine plus sine, which is just going to be 2 sine in the top. And what about the bottom? Does that simplify? Well, we could FOIL this out, right? We could say 1 squared times 1 times negative cosine, cosine times 1, and cosine times negative cosine, or we could use that OCD method with the box. But also remember, this is a binomial square pattern. You have a 1 here, which is the same number, and a cosine here, and they're alternating signs. So we actually know that that's going to FOIL into 1 squared minus cosine squared. And we don't even need the 2 there because we know that 1 squared is just 1. Okay, so now what? Well, at this point, alarm bell should be going off that you see this 1 minus cosine squared. Looks a lot like a Pythagorean identity. In particular, it looks a lot like the Pythagorean identity, sine squared plus cosine squared is equal to 1. So how do we get this one? Well, all we have to do is just subtract cosine squared from both sides to get kind of a different version of the Pythagorean identity. And that's going to give us, we bring the sine squared down, is equal to 1 minus cosine squared. And so that bottom there is going to be equal to, let's write right at the top, 2 sine of theta. It's actually just going to turn into just sine squared. Okay. Notice anything else? Well, we have a sine in the top and a sine in the denominator, so the sine will cancel here. But this one is 2 sines multiplied by each other, so we don't want to cancel the whole thing. We just want to get rid of one of them. So we change the square to just a 1. So that leaves us with 2 over sine. And because the sine is in the denominator, we could put it in the numerator, but we have to change it to a cosecant. And that is as simple as that one is going to get. Alright, let's look at number 4. So number 4 says, find the value of secant and cosine, respectively, if tangent of theta is equal to 1 and cosine of theta is greater than 0. How do we do this one? Well, the thing is that we're only given the numerical value for one of the trig functions, whereas up here we were given 2 in number 2. So whenever you're given 1, you're going to actually have to use a Pythagorean identity to relate it to another one. And if you look at your Pythagorean identities, there is one with tangent. We know that tangent squared of theta plus 1 is equal to secant, which is actually nice because that's one of the ones we're asked to find here. And so we say, okay, well, tangent squared, well, that's we know that's 3, so we'll just say 3 squared plus 1 is equal to secant squared. We know that 3 squared is going to give us 9, and then we add 1 to that. That's going to be 10 is equal to secant squared theta. And whenever we have a square, we can get rid of that by taking the square root of both sides. So we get that secant is equal to the square root of 10, but remember, if you square a square root, you will need the plus minus in front. So the challenge here is actually that square plus minus the square root of 10 is equal to secant. Well, which one is it? Is it the positive secant or the negative secant? Well, we can use this other piece of information up here that tells us that cosine is greater than 0. And if you think about it, cosine, once again, is the reciprocal identity of secant. So what we're going to do is, we say, well, if cosine theta is greater than 0, then that means that secant of theta, which is just 1 over cosine would be the same thing as 1 over secant. Well, if I have 1 and I divide it by secant, right, and that's going to give us the same thing as cosine. Well, those two should both be positive. If cosine is positive, secant then has to also be positive. So that gives us that it's just the positive square root of 10. And again, well, if I want to find cosine, which is the other one I'm asked to find here, well, we really don't need to fret, because again, secant is just 1 over cosine, right? So if secant is just 1 over cosine, or we can just use the reciprocal of what secant is, well, the reciprocal of the square root of 10 is going to be 1 over the square root of 10. And again, we already know that it's positive, so those two are our answers there. Okay, let's go on to number 5. So number 5 says, for all values of theta, what is equal to the following? So what we have to remember here are our odd and even identities. And so let's run through them and recall them as we go. So we know that cosine is just going to stay there. Tangent, we don't do anything to that. Cosine with a negative inside, we have to remember that whenever I put a negative inside of cosine, nothing happens to it. It just stays as cosine. So the cosine of negative theta will actually just turn back into cosine. Tangent's a different story though, because with tangent, recall that if I have tangent of negative theta, that's the same as pulling the negative in front of the tangent as such. So that actually is going to be minus tangent here. And sine is actually the same story, right? Sine, I also pull the negative out. So that means that sine of negative theta is minus sine of theta. Alright, so now that we've turned these using the odd and even identities, let's see if we can't simplify. We notice we have a positive tangent and a minus tangent, so those two will just go away. We have 2 cosines, so those two will add together to just be 2 cosine of theta. And then minus sine is at the end here. And there's really nothing else we can do with that, so that is simplified as much as it can be. Okay, let's look at 8. So we're asked, what is secant times cosecant times tangent minus 1 equal to? Well, remember the main strategy in doing trigonometric identities is you want to turn everything into sine and cosine if it's not already in sine and cosine. So secant, we talked about it earlier, that's just 1 over cosine. Cosecant is the other one, so that's 1 over sine. And tangent, well, tangent really is just sine over cosine. And then remember we have a minus 1 writing behind everything. Okay, well, we notice that these two signs, there's a sign in the numerator and denominator. So we're just going to end up with a 1 in the top. But over here, cosine times cosine is actually going to be cosine squared minus 1. And what now? Well, 1 over cosine squared. Remember, 1 over cosine, like we said up here, is secant. So that's actually just going to turn into secant squared minus 1. And what is this? Well, again, a trigonometric value with a minus 1 or 1 minus it should send off alarm bells that you might be dealing with a Pythagorean identity. And that is the case here. So if you look, we see that tangent squared plus 1 is equal to secant squared. We want to get secant minus 1, so let's subtract 1 from both sides. So that just gives us that tangent squared is equal to secant squared minus 1. And that basically just means that this will turn into tangent squared here. And that is what it is. So all of this stuff up here turned out to be just tangent squared in disguise. Alright, let's do number 7. So number 7 says, if cotangent of theta is equal to negative 1/5 and tangent is less than 0, find cosecant. Okay, so again, we're only given one trigonometric value here. So in that situation, when you're only given one trigonometric value, you want to use a Pythagorean identity to try to find the others. So we know that sine squared plus cosine squared is 1. So I'll just say sine squared plus negative 1/5 squared instead of cosine here is equal to 1. Again, we're using the Pythagorean identity here. Okay, well, we just square 1/5, and how do you square 1/5? Well, again, you square both the numerator and denominator separately. So we're going to get sine squared of theta plus 1 squared is just 1, 5 squared is 25, should be equal to 1 still. Okay, so let's solve for sine. We subtract 1 over 25 on both sides. That gives us sine squared is left on the left. Now, if you have a hole and you're taking away one of a piece that's cut into 25 pieces, again, I tell my students to think of like pizza. If I have a pizza that's cut into 25 slices, and you eat one of those slices, that takes away one from that whole, or you're left with 24 slices. So that's kind of an intuitive way to remember that. And then to get rid of this square, what do? Well, you just take the square root. And what's cool is that square roots work very similar to exponents in the sense that if you take the square root of a fraction, you want to do both the top and bottom. So we just do the square root of 24 because there's really nothing we can do with the square root of 24. That's not a perfect square. But we should know that the square root of 25 is just 5. But again, you need the plus minus because again, you're square rooting a square. What now? Okay. Well, now you have to find cosecant. Well, cosecant is actually the reciprocal identity of sine. So we know that cosecant is going to be 5 over the square root of 24, but again, it has to be plus minus because we don't know if sine is plus minus either. So how do we decide between the two, whether it is positive or negative? Well, we know that tangent is less than 0. But we also know that tangent is sine over cosine. And let's see, so tangent's negative. Well, we know cosine is negative because cosine is negative 1/5. So the only way that this could possibly work is that to divide by something that's negative and to get a negative, you have to have a positive in the top. So that means sine is just positive square root of 24 over 5. And thus that means that cosecant is positive 5 over the square root of 25. And that is it. Alright, let's look at number 8. So we're asked, what is equal to sine squared times cosine times secant squared plus cosine cubed, with a 3 there, and secant. Now, unfortunately, I kind of flubbed on this problem, so go ahead and put a little exponent with a 2 on secant if you could. So what do we notice? This is a 2. That didn't really write that clearly. There's a 2 exponent on that. So what we want to do is let's factor out everything that is in common across the two, across the addition sign. So we see that, okay, there's not a sign over here. We see that there is a cosine in the first one, and cosine cubed means there's actually 3 cosines getting multiplied here. We'll underline that, but we have to remember that when we factor stuff out. We also notice that there's a secant squared on both. Okay, so we factor everything that's in common out. Now, we create a parentheses. Now notice again that there is just one cosine, so we're only allowed to take out one cosine because this one only has 1. This actually, because it has 3 cosines, if we're taking one out, we're going to leave 2 there. And then we also pull out the secant squared because it's in both. Alright, what's left over? That goes inside the parentheses. Well, that's just going to be sine squared and cosine squared on this side. Now that's nice because sine squared plus cosine squared is just 1. We know that's a Pythagorean identity. So that's just, we don't have to worry about that anymore. We just have this stuff in the front to concern ourselves with. And where do we go from here? Well, again, secant is just going to be 1 over cosine, because the secant squared, the cosine in the denominator has to be squared. And that shows us that we're multiplying cosine by 2 cosines in the denominator. So that will cancel because this is in the numerator. Remember, a whole number times a fraction. The whole number in front is technically in the numerator. If I wanted to, I could say cosine over cosine squared, but I wanted to kind of leave it in the same sort of form. And the 2 at the bottom here cancels with one of those, but we're left with a 1 there. So we're left with a 1 over cosine. But again, whenever we have 1 over cosine, we're going to want to go ahead and turn that into secant. So all of this stuff we see is actually just equal to a single secant. All right, let's do 9. So here, this is actually the point at which it goes into the next part of the lesson after the quiz that we took. So this says find all solutions of the equation on the interval 0 to 2 pi. Well, remember when you're solving trigonometric equations, the big thing, the strategy you want to remember is to try to isolate your trigonometric expression. So in this case, sine x. Also, the 3, go ahead and make that a square root of 3 for me. Again, this flub in the typing, my bad. So how do we get the sine x by itself? Well, first, let's go ahead and subtract the square root of 3 from both sides. So that gives us 2 sine of x is equal to negative square root of 3 over, nope, not yet. Now, see, I stepped ahead there, right, because I knew it was coming next, but 2 sine of x is equal to negative the square root of 3. So how do we get sine by itself? Because remember, that's our goal. Well, let's divide both sides by 2, and now let's do that. You don't have to make that big one there. If you didn't flub it, I just messed up. But it's the square root of 3 over 2. But the 2 on the lefts cancel. So we get sine of x is equal to negative square root of 3 over 2. So now what? Well, again, what we want to think about this is in terms of the unit circle, and think, what angles on the unit circle would give me a negative square root of 3 over 2 in the sine? So remember, on the unit circle, sine is the y coordinate. You want to associate it with the y coordinate on the unit circle. So what you want to do here is say, well, that angle is going to have to be, look on my unit circle, and I see that negative square root of 3 over 2 is going to be 4 pi over 3, and 5 pi over 3. And those are the only 2 places where sine would give us a negative square root of 3 over 2. And that is our answer. Okay, so let's go to 10. So 10 says find all solutions of the equation on the interval 0 to 2 pi. So again, that just means we're going around the unit circle once. So same sort of strategy here as number 9. We want to isolate this trigonometric expression. So let's go ahead and subtract 4 from both sides. That gives us that 4 cosine squared of x is equal to 5 minus 4, which is just 1. Let's go ahead and take both sides and divide by 4. So that's going to cancel that 4 on the left. So we're left with cosine squared. I'm going to move stuff over here for more room. Is equal to 1/4. And now what? Well, it's cosine squared is equal to 1/4. So to get rid of that square, I want to take the square root of both sides. So that's going to give us cosine of x is equal to the square root of 1/4. And again, with the square root, when you're taking the square root of a fraction, square root of the top, which is 1, square root of the bottom is 4. Notice anything we might have forgotten? Yep, if you square a square root, you need to put a plus minus in front of that number. Now in this case, what this is saying is that I need to find all the places where all the angles x that would make cosine on my unit circle positive or negative 1/2. So anywhere in the x coordinate on the unit circle you see a positive or negative 1/2, that's going to be our answer here. That's going to be our angles that would make cosine plus or minus 1/2. So I look on my unit circle, that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are my 4 answers here. Okay, so let's do number 11 here. So we're told to find all the solutions of the equation on the interval 0 to 2 pi. Now this is kind of an unusual situation here because we have a sign in both terms. There's a cosine times sine and a sine on the right side. So what we want to do here is we actually don't want to isolate our trigonometric variable, our trigonometric function. We actually want to get everything on one side and get one side equal to 0. So we're going to subtract sine of x on both sides. Now again, a very common mistake here would be to think, oh well, this maybe is getting rid of this sign, but again, you can't do that because this is cosine sine, it's not just sine. So you actually have to write this out as cosine times sine minus that sine that we just subtracted. And because there's nothing left on the right side after I've subtracted the sine out, that's just going to be 0. So why would I have done that? Well, the reason is because I noticed that this now puts sine in both terms, so that means I can actually factor that sine out of the equation. So I could say sine of x, parentheses, cosine of x, because that's what was left over. And then because this is just sine x and we took that away, we want to put a minus 1 here. Okay. So what that does now is that actually gives us two separate versions of the solution here. Because here we have the sine x times cosine minus 1. So it's and multiplying them together equals it to 0. So it's either going to be the case that this sine x is equal to 0 or the cosine x minus 1 is equal to 0. And we want to solve this one in this case to isolate it by itself. So that gives us that cosine x is equal to 1. Alright, so here we're given that there are these two pieces of the solution. So we have to say, well, x is going to be equal to whatever angles that would either make sine or the y-coordinate on the unit circle 0, or cosine of x equal to 1. So the angles that would make the x-coordinate 1. The first one, if we go around, is that we see 0. And if you look on your unit circle, you'll see that at 0, the cosine of the x is 1 and the sine is 0 in both cases there. So 0 is our first answer. Our second answer is pi, and if you look, again, that's where sine is 0. Cosine is not 1, but again, it doesn't have to, the angle we want doesn't have to be either one or the other, or have both. It can have either one or the other. So if sine of pi is 0, then that's all that matters. Cosine of pi doesn't have to be 1 there. And then our next one is, remember, if we go all the way around, that's going to be the same thing as 0. So we also want to put 2 pi because 0 and 2 pi basically have the same coordinates. That's our answer. Alright, let's look at 12. So 12 says, find all solutions of the equation on the interval 0 to 2 pi for cosine squared plus 2 cosine x minus 1 is equal to minus 1. So what we're going to want to do here is let's, again, because we have cosines like this, and I can't add them because this is cosine squared, and this is just cosine with a single exponent, let's try getting this equal to 0 and see what happens. So we get cosine squared of x plus 2 cosine of x plus 1 is equal to 0. Well, here again, I want to treat cosine of x like it's x in some sort of quadratic equations problem. And so we put the number 1 up here and the coefficient in front of the cosine, negative 2. So what that tells us is, again, we want to look for two numbers that multiply to 1 but add up to, oh, sorry, why did I put minus? That's plus. Interesting. So again, we want to do it to where they add up to 2 but multiply to 1. That's easy. That's just 1 and 1. And so that's going to mean that this equation is going to factor into cosine of x plus 1, cosine of x plus 1 is equal to 0. Now, I could say cosine of x plus 1 is equal to 0, cosine of x plus 1 equal to 0, just like I did over here. But because it's the same thing, you only need to put it once. So cosine of x plus 1 is equal to 0. Again, let's get cosine by itself. So we get that cosine, again a little messy here, is equal to just negative 1. And again, same procedures as the others. Now that you've isolated the trig function, you want to look for the angles that will make cosine or the x-coordinate on the unit circle equal to negative 1. And there's actually only one spot where that happens, and that's at pi. There's our answer. Alright, let's go ahead and look at 13. So 13 says the velocity of a particle moving along a horizontal line is given by the function Vt is equal to 2 cosine squared t minus the square root of 3 cosine t. Over the interval 0 to 2 pi, when will the velocity of the particle be equal to 0? So this seems a lot more complicated than it is, but it really isn't, because what we have to realize here is that, well, this is actually the function that gives us the velocity with respect to time. So if we're asked when is the velocity, when will it be equal to 0, we just have to set this equation equal to 0. So I'm actually going to write this on the left. And remember, it doesn't matter what goes on the left and what goes on the right. So I'm writing this part of the equation, and that should be equal to, instead of Vt, we're just going to write 0 instead, because we're wondering where is this velocity equal to 0. Okay, so this is not like 12 because there's a 0 over here, so there's not a constant associated with this trig function. So, but because of that, we notice that there is a cosine of t in both terms, so that means we can actually factor that out. And on the inside, well, cosine squared, if I took out a cosine, that's just going to leave the cosine of t, just one of them. And again, remember there is a 2 in the front there. And then if I took the cosine of t away from this, that's just going to leave the square root of 3, and that's equal to 0. Okay, so now we've written this equation, and what this means is that, well, either cosine of t is going to be equal to 0, or this thing over here, 2 cosine of t minus the square root of 3 is equal to 0. And let's solve this one. Plus the square root of 3 on both sides. That gives us 2 cosine t is equal to the square root of 3. And then we can divide by 2 on both sides. That gives us that cosine of t is equal to the square root of 3 over 2. So what we're going to need to do here is figure out, well, what t's or what angles can we put inside of these cosines that would give us either cosine of 0, or the x-coordinate on the unit circle is 0, or would give us a x-coordinate on the unit circle with the square root of 3 over 2. So we look on our unit circle. Well, the first one that's going to give us a cosine of 0 is pi over 2. Let's knock those out first. And 3 pi over 2. Those are what will give us those radians will give us a cosine where the x-coordinate is 0, right? But we also have to remember we're looking for the angles that would make cosine of t equal to the square root of 3 over 2. And again, looking on our unit circle, where's that going to happen? Well, that's going to happen where we have a radian of pi over 6 or 11 pi over 6. And those 4 radians will be our answer. Okay, so let's go ahead and finish these notes off. So we're asked to find the exact value of the trigonometric expression cosine of 15 degrees. Now again, if you look on your unit circle, you're not going to see a 15 degrees. So what you have to do is use your sum and difference identities and say, well, how would I do that because I have a 15? Well, again, notice that 15, I can break that into 2 trig identities by saying that is 45 minus 30 degrees. And I say, okay, well, so that's going to make this cosine of 45 minus 30. Now, why does that matter? Well, because again, remember that if you look on your sum and difference notes, recall that if you're subtracting 2 things inside of a cosine, that's going to give us cosine of A times cosine of B plus sine of A sine of B. So I can use that to break this cosine down. So I can say that cosine of 45 minus 30, well, that's just going to be cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Okay. So what is cosine of 45? Well, for these, we just get to look on our unit circle because these are the values on our unit circle. So the cosine of 45 is just the square root of 2 over 2. The cosine of 30, well, that's just the square root of 3 over 2. And again, be sure you look on the unit circles to confirm these. The sine of 45, that's also the square root of 2 over 2. And sine of 30, that is 1/2. So, okay. So now, the square root of 3 over the square root of 2, remember if you have two square roots over something, you can actually multiply those together with the square root over them. So that's the square root of 6. 2 times 2 is 4. So remember with fractions, we go across the top, across the bottom. Here, square root of 2 times 1 is just the square root of 2. And 2 times 2, that's 4 again. And because these have that common denominator, we just have to write it once and say the square root of 6 plus the square root of 2 is our answer. All right, let's do 15. So 15 is a bit different from 14 because here we have a theta plus pi over 4. So how do we do this one? Well, again, we use a sum and difference identity. This one actually is going to be that the cosine of theta plus pi over 4, we use the cosine with a plus inside. We say that that's going to be cosine of A, cosine of B, minus sine of A, sine of B. So cosine has the different one. If you have plus A plus B, it's actually a minus in the middle. So we just use that. We say, well, okay, well, that's just going to be cosine of the first thing, theta, times cosine of the second thing, pi over 4, minus sine of the first thing, theta, times sine of pi over 4. What is, let's see, well, cosine of theta, can't really do much with that. That's just cosine of theta. But we do know that cosine of pi over 4, if I look on my unit circle, is the square root of 2 over 2. And then the cosine of theta will hang along for the ride. Sine of pi over 4, well, that's just also the square root of 2 over 2. And then that leaves sine theta on the outside. And all we have to notice here is both of these terms have a square root of 2 over 2, so we can actually factor that out, put it in front, and that's just going to make us cosine theta minus sine theta, which is our answer. Alright, let's look at 16. So 16 says find 2 theta and cosine of 2 theta for the given value in interval. And we're given that sine theta is equal to 4 over 5 over the interval pi over 2 to pi. Alright, so this is the one where you actually have to draw out the triangle on the xy plane. And so remember, so this is telling us that our interval is from pi over 2 to pi. So that means that's 0. Remember, this is pi over 2, and this is pi. So it's going to be somewhere over here. So let's draw a triangle over here. And the dimensions of our triangle are given to us by sine. Again, sine is opposite over hypotenuse. And because it's the angle, the side opposite to that will be 4. The hypotenuse of this triangle is 5. And hopefully you notice that, again, this is a 3, 4, 5 triangle, so we can just write a 3 there. But again, be careful because the 3 this is the x coordinate, and because it's to the left of the y-axis, we're actually going to have to make that a -3. Alright, well, if we look at our sum and difference identities notes, we know that sine of 2 theta is just going to be 2 sine times theta times cosine of theta. So we can just, to get sine of 2 theta, which is what we're asked for, we just plug in sine of theta and cosine of theta. So that's going to be 2 times sine of theta, which we're given in the problem is 4 over 5. And cosine, what would cosine be? Well, cosine is adjacent over hypotenuse. So in order to get that, we're going to actually have to say, okay, well, what's the adjacent side? What's touching the angle? Well, that's -3. And on the bottom, with just like sine, the hypotenuse is what we want. So we put a 5 down there. Okay, so doing that, well, again, let's go ahead and multiply all this. So with fractions, we just go across the bottom, across the top. The bottom is 5 times 5, which is just 25. And again, the 2 is like it's in the numerator. So we want to multiply 2 times 4 times -3. I would do 4 times -3 first, because that's -12, and then you just got to double that with the 2 to get -24, which is our first part of our answer. But now if we want cosine of 2 theta, which is what we're also asked for, we actually have 3 options if you go back and look at those notes. I'm going to use this one, and again, any of the others will work, but there's one that just says cosine squared minus sine squared. And so I just plug into this one. Cosine, again, is just negative square root of 3 over 5 with the square, minus sine, which would be 4 over 5 squared. So remember, when you're squaring a fraction, you want to do both the top and bottom. So 3 squared is 9, 5 squared is 25, and because you're squaring a negative, the negative just goes away. Minus 2 squared, or 4 squared is 16, 5 squared is 25, and 9 minus 16 is -7, and then we have the 25 as our common denominator. So those are our answers there. Okay, let's look at the last page. So for 17, we have something about projectile motion. The problem says a ball is thrown with an initial speed, initial speed v naught at an angle theta that travels a horizontal distance d will remain in the air for t seconds. If t is equal to d over initial velocity vo times cosine theta, suppose a ball is thrown with an initial speed of 50 feet per second, travels 100 feet, and is in the air for 4 seconds. Find the angle at which the ball was thrown. Let's find out. Well, first of all, whenever you're doing these word problems, try to make it so that you identify what all of the things you need to plug in are. So first things first, we see this says initial speed of 50 feet per second. So that's just our initial speed, the VO, that's what we're going to plug in there. Travels 100 feet, that's our distance that it traveled. And it's in the air for 4 seconds, that's just our T. So we just plug all that stuff into our formula. So T is going to be 4 is equal to D, which is 100, over the initial speed, which is 50, and we want to multiply it by the sine of the theta because we don't know what that is. On the right, let's clean this up a little bit. So 100 divided by 50, well, we know that's just 2. So this actually is going to become 4, move down here now, 4 with a 2 in the top over cosine of theta. Here, cosine of theta, which is what we want to solve for, is in the bottom, that's no good. So let's multiply it by both sides. So we get 2 is equal to cosine of theta with a 4. Typically you put the numbers in the front, so that's what I did here. And then I'm going to go ahead and divide both sides by 2. Sorry, not by 2, by 4, excuse me. So divide both sides by 4. We get that cosine of theta is equal to 2 over 4, which is just 1/2. Now in this case, what I want to do is say, okay, well, what angle would give me a 1/2, right? And if you think about it with projectile motion, if I'm just throwing something, I just really need one angle here. I just don't need the other one. So you could take the arc cosine of both sides. That's totally fine. And then the arc cosine gets rid of the cosine, so we get that theta is equal to the arc cosine of 1/2. And the arc cosine of 1/2, well, that's just going to be actually 60 degrees. And the easier way to get that is, again, to think what value or what angle would give us a 1/2 as cosine, and if you look on your unit circle, that is 60 degrees. Okay, so that's actually the last question for the pre-AP classes. If you're doing pre-AP, go ahead and watch the rest of this because this problem will be on your test. If not, you're actually done. So that is the end of the review for some of you. Okay, if you're pre-AP, hopefully you're still watching. Let's do this last free response problem. So we're told a soccer ball is kicked from the ground level with an initial speed of, we're going to pretend that I put 50 here, so put a 50 there if you would, thank you, feet per second at an angle of elevation of theta. The horizontal distance d is given by the equation d is equal to v squared sine of 2 theta over g, where v is the initial velocity and g is 32 feet per second squared. That should look somewhat familiar to you, maybe from physics. That's just gravity's pull. Find the angle of elevation if the ball traveled 75 feet. Didn't have very good English there either. Alright, so again, we just like the last one, we just want to plug stuff in. So what we're going to do here is say, okay, well, what is our g? We know is 32. So let's actually write this out. So I'll put an equal sign. The distance it travels, the d, was 75, so we'll put that on the left. In the top, the initial velocity, we're told that that is 50 feet per second. Remember, you got to square that because the formula says that that gets squared. With the sign of 2 theta behind it over the gravitational constant, so instead of g, we just put 32 down here. Okay, so we want to isolate that trigonometric expression. So let's go ahead and multiply both sides by 32 first to get that. That cancels that 32 in the denominator. That gives us 32 times 75, which is 2400. 50 squared, well, you could do this in your calculator, but if you think 5 times 5 is 25, and then multiplying 50 has 2 zeros, so I'm going to put a 2500 there. And sine of 2 theta is still chilling back here. Okay, so again, let's isolate that trig expression. Let's divide both sides by 2500. This will cancel. We get that sine of 2 theta is equal to 2400 over 25. We can actually simplify that because you'll notice there's concurrent zeros in the top and bottom, so that actually would just be 24 over 25. Makes it a little simpler for us later. Alright, so now what? Well, again, we want to know what thing would go inside of sine to give us 24 over 25. To get that, because it's not on the unit circle, we actually do have to do the arc sine here on both sides. Just going to do it with the 24 over 25. Arc sine gets rid of sine, so we get that 2 theta is equal to the arc sine of 24 over 25, which we find out to be 73.74 degrees. But again, remember there is another angle here, because here, remember if we have like the top half of our unit circle, I'll explain this one more time. The coordinate that would give you the 24 over 25 over here, which we just found out is 73.74, is also going to give you, there also should be another x coordinate where 24 over 25 is over here as well. But to get this one, this 73.74 is actually the reference angle for that angle. So if I want to find it all the way around, I take 73.74 and I subtract 73.74 from it. And that's going to give us 106.26. And that's actually the other angle here. Alright, now we go ahead and divide both sides by 2. And because we actually have two angles, we have to kind of think of them as two solutions to this. So we have to actually divide both by 2. 73.74 divided by 2, well, that's just 36.87. And 106.26 divided by 2, that's 53.13. And so what that tells us is that the angle we want is between 36.87 and 53.13. So basically what this is saying is that in order for the ball, in order for to travel that distance, so in order for the soccer ball to travel this distance with an initial speed of 50 feet per second, and a velocity of, a distance we want to travel 75 feet, we'd have to kick that ball between 36.87 and 53.13. Alright, so that is it. So everybody, hopefully you got something out of that, and I will talk to you guys later.